Yo, what's up? It's your boy, Mr. AC. And what I got for you guys today is going over primarily, and we are on year number. So let's go ahead and get started. Question 2008. This was requested via email, so I wanted to make sure to send this over to you guys. I realized that this problem, I kind of left it as an exercise for you. I'm going to skip part A and I'm going to skip part B, and we're going to talk about part C, but I did do part B right here. I at least will walk you through it so you can at least understand what we did. We multiplied dx to both sides like this. Boom, dx to both sides, cancel out. We divided by y minus 1 to both sides, and so it's going to look like this to the right here. Now, this problem over here can be rewritten as x to the negative 2. You can put it back on top because it has a exponent. So I did the work right here. Now I take the antiderivative. This would be ln absolute value y minus 1 absolute value is equal to. And then if I was to write this as negative 2, I add 1, which I did right here. Negative 1, we divide by it. So this would be it. And all I did was take this and I just flipped it and put it underneath here. I plugged in my values, 0. For the y value, 2 for the x value. So we get ln of absolute value of 0 minus 1. This would be negative 1. Absolute value of negative 1 is 1. ln of 0 is 0. And I plug these in, we get negative 1. We're going to add 1/2 to both sides, and we get c is equal to 1/2. Once we figure that out, we plug it back into my function. All right, so for a quick moment, ignore my e's real fast. I just take the c value and I plugged it in right here into this one right there. You can pause it if you need to. And then when I did that, then I raised it e to both sides to get rid of ln. These cancel. I get y minus 1 is equal to e raised to this power. We add 1 to both sides, and there is my function right here. So what do we do now? Well, what we're going to have to do is part C. It says find the particular solution y equals f of x described in part B. We did that. We found the original equation right here. And then it says to find the limit as x approaches infinity. I cut it off by accident, right? If I was to show you the original problem as x approaches infinity right here. So we're going to take and we're going to do the limit as x approaches infinity of this function. Well, how do we do that? Well, like normal, this is a limit problem. We're going to take infinity and we're going to plug it in. So we're going to get e to the negative 1 over infinity plus 1/2 like this plus 1. Well, look at this expression here. What's going to grow bigger, the top or the bottom? Well, the bottom grows bigger than the top. So what will this entire thing become? It's going to become 0. So this is actually going to become e to the 0 plus 1/2 like this plus 1. Well, what is 0 plus 1/2? That is e to the 1/2 plus 1. So then now I can conclude, hey, the limit as x approaches infinity of this function is this right here. And that was really it. All I wanted you to do was find your original. And when you did, you would do the limit as x approaches infinity. Now, sometimes you just figure out what grows bigger, top or bottom. But in this case, I just plugged it in and then I worked from there. Bottom grows bigger than the top. This is 0. You're left with this expression. You keep it there and then you're left with the plus 1. So hopefully that makes sense with part C. It's a little bit of a tricky one, but hopefully plugging it in and just kind of going through it helps make sense of this problem. All right, y'all, take care. Capiche?